ladies, this is lesson 4.7. It's about completing the square. So you may have done a little bit of this last year. That's maybe a little bit of review, but it's going to be a little more complex than what you did in Algebra 1 or Advanced Algebra 1. So we're going to look at the first term, this first vocab term. It says completing the square. You're going to add a term to an expression. The expression x squared plus bx. You're going to add a term, the c term here, to make this a perfect square. So if you remember our shortcut from lesson 4.3, I think it was, maybe 4.4, it was a plus b squared equals a squared plus 2ab plus b squared. And then our other part was a minus b squared equals a squared minus 2ab plus b squared. So this is what we're trying to do. We're trying to make this quadratic expression a perfect square. So to do that, we're going to add b over 2 squared. So x squared plus bx plus b over 2 squared equals x plus b over 2 times x plus b over 2, which is x plus b over 2 squared. So again, we've worked with these kinds of things before, but now we're looking for that constant term that we don't have. Before we had it and we were factoring it, now we don't have it and we're using factoring to look for it. So to make a perfect square trinomial, we want to find the c that makes x squared plus 12x plus c a perfect square trinomial. Then write the expression as the square of a binomial. So just like we did, a plus b squared is a squared plus 2ab plus b squared. So first we want to find the coefficient of x. Here is our coefficient in front of our x term. So that's 12. And then we're going to divide that by 2, which gives us 6. The second step is to square that result. So 6 squared equals 36. And then we're going to replace c with the result of step 2. So now we have x squared plus 12x plus 36. And this is not an equation right now, it's just an expression, so it doesn't equal anything. So the trinomial x squared plus 12x plus c is a perfect square when c equals 36. So then x squared plus 12x plus 36 is x plus 6 times x plus 6, which is x plus 6 squared. So please feel free to pause or rewind as you need to make sure that you're keeping up and that you understand what's going on. So for the next part, we'll do another one together and then you'll try the second one on your own. But we want to find the value of c that makes the expression a perfect square trinomial. Then write the expression as a square of a binomial. So our first step is to find the coefficient for x and divide that by 2. So our first step is negative 24 divided by 2, that equals negative 12. Our second step is to square that result. So negative 12 squared equals 144. And then our third step is to replace our c term with that 144. So we get x squared minus 24x plus 144. And then we can write that as a square of a binomial. So x minus 12 times x minus 12 equals x minus 12 squared. So try the next one on your own. Please pause the video while you work and unpause for the solution. First step is to divide the b term, the coefficient of x, by 2, so we get 5. Next step is to square 5, so we get 25. Then next we replace c with 25. And then finally we can write that as an expression that is the square of a binomial. So x plus 5 squared, where a squared plus 2ab plus c squared is our expression. All right, let's look at the next one. Now this is a little bit different because we have a c term already. So if the c term is not a perfect square, then you have to move it to the other side of the equation. So before we were just working with an expression, now we're looking at an equation. So let's rewrite the equation. X squared minus 10x equals negative 13. So our first step is the same as in the last example, and that was to find half of the coefficient of x. So negative 10 divided by 2 equals negative 5. Our second step is to square that. Negative 5 squared equals 25. And in the last example, we just replaced c with that because it was just an expression, it was not an equation. But now since we have an equation, if we're going to add 25 to the left-hand side, we have to add 25 to the right-hand side. So now we get x squared minus 10x plus 25 equals negative 13 plus 25. So whatever you do to the left side, you have to do to the right side. Then I'm just going to rewrite my equation to simplify. So x squared minus 10x plus 25 equals 12. All right, now my next step is to write as a square of a binomial, so I can do that on my left side. So I'm going to continue up here. So I get x minus 5 times x minus 5 equals 12, which is the same as x minus 5 squared equals 12. Now I want to solve for x. That's my goal. So in order to do that, I can take the square root of both sides. So I get x minus 5 is the square root of 12. And then I can simplify the square root of 12. So x minus 5 equals positive or negative 2 times the square root of 3. So I get x equals positive or negative 2 times the square root of 3 plus 5. All right, so let's try another one that's similar to that one. But this one, you have your coefficient in front of your x squared term is not 1. So again, we're going to solve by completing the square, but we're going to try to get back to that very general formula that we were using at first. So since we have an equation, we've got 3x squared minus 12x, and we have a c term, but it's not a perfect square, so we're going to move it to the other side, equals negative 27. And we want to get rid of that 3 in front of the x squared term by dividing each term in the equation by 3. So we get x squared minus 4x equals negative 9. Okay, now we can follow our steps for completing the square. So our first step is to take half of the coefficient in front of x, which is -2. Our second step is to square that. And then our third step is to add that to both sides of the equation. So we've got x squared minus 4x plus 4 equals -9 plus 4. So now we can put the left side into a perfect square binomial. So that's x minus 2 times x minus 2 equals -5, which is x minus 2 squared equals -5. Now we're solving for x, so I'm going to move my stuff up here so that you can see the whole thing. So we're solving for x, so we want to take the square root of both sides. So we've got x minus 2 equals -5, equals the square root of -5. So if you remember from the last lesson, the square root of a negative number is I times that square root. So x minus 2 equals I times the square root of 5. So we've got x equals I times the square root of 5 plus 2. All right, and then let's look at a couple other problems. You should try these ones on your own. So we've just done examples like this. So please try these next two on your own, and you can pause while you work and unpause for the solution. All right, so the first one is you do not have coefficient in front of your x squared term, but you do have a c term that is not a perfect square, so you need to move that to the other side. And then you need to find half of your coefficient in front of x, which is -4, and then square that to get 16, and add 16 to both sides of the equation. So you end up with x squared minus 8x plus 16 equals 9, which is the same as x minus 4 squared equals 9. So then you can take the square root of both sides to get x minus 4 equals positive or -3. So then when you add 4 to both sides, you're either adding 4 to positive 3 or adding 4 to -3 as your solution. So -3 plus 4 is 1, and positive 3 plus 4 is 7. So your two solutions are x equals 1 or x equals 7. All right, so your first few steps for the second problem are 2x squared minus 20x equals -24. Since 24 is not a perfect square, you need to move it to the other side of the equation. And then you end up with x squared minus 10x equals -12. So now you can find the half of your coefficient in front of x, which ends up as -5. And then you want to square -5 to get your missing c term for the left side of the equation. So you get x squared minus 10x plus 25 equals -12 plus 25, which is x squared minus 10x plus 25 equals 13. So now our next step is to put that into a binomial square. And then once we do that, we can solve for our x term. So we get x minus 5 squared equals 13. Take the square root of both sides, we get x minus 5 equals the square root of 13. So we get x equals the square root of 13 plus 5. All right, so let's look at the next couple examples. And this is about vertex form. So remember, vertex form is y equals a times x minus h squared plus k. That is your vertex form. We worked with that earlier this chapter as we were graphing quadratics. So we're going to follow the same steps, but actually it's one last step because we don't have to actually solve for x. We want to just identify the vertex. Right, so we're doing vertex form. It's, again, a little bit simpler because we don't have to solve for x. We just have to put it in the a times x minus h squared plus k form. And remember that this is x minus h. So our vertex is going to be hk, but if in vertex form it's x plus h, then our h is a negative number, and if it's minus k, then our k is a negative number. But otherwise, if it's x minus a number plus a number, then we've got just our h and k. Alright, so we're going to walk through the same stuff that we did for the earlier examples. And again, if we have a C term that is not a perfect square, like in this case, 44 is not a perfect square, we are going to move that to the other side of the equation. So we've got y minus 44 equals x squared plus 14x. Now our first step is to find half of our coefficient in front of x. So 14 divided by 2 is 7. And then our second step is to square that term. So now since we have an equation, we're going to add 49 to both sides. So we get y minus 44 plus 49 equals x squared plus 14x plus 49. So that's y plus 5 equals x squared plus 14x plus 49. And now we can turn that right side of the equation into a binomial square. So that gives us y plus 5 equals x plus 7 times x plus 7, which is x plus 7 squared. Now, in order to get this into vertex form, we need to say y equals. So we need to subtract 5 from both sides. So that gives us y equals x plus 7 squared minus 5. Now let's look at this for a second, because we want to, the next step is to find our vertex. Identify the vertex. So we want to identify our h and our k. Remember, vertex form says x minus h, so our h is negative 7. Because we have x plus 7, so our h is negative 7. And then our k, x minus h squared plus k. So in this case, we are adding a negative 5. So our vertex is negative 7, negative 5. All right, now let's look at a couple of examples. You can try those on your own. Please pause the video while you work. You can unpause for the solution. All right, our first step is to move that 22 to the other side of the equation because it's not a perfect square. Then we want to find half of our x, our coefficient in front of x, which turns out to be negative 6. Then we can square that and add that number to both sides of the equation. So we get y equals, or sorry, not y equals, y plus 6 equals x squared plus 12x plus 36. Our next step now is to put that right side of the equation into a square binomial. So then finally, after you put it into a square binomial, we get y plus 6 equals x plus 6 squared. So we get y equals x plus 6 squared minus 6. That's vertex form. So our h is negative 6, our k is 6. Our vertex is negative 6, 6. Oh, I have to apologize. If you're checking your answer, I made a sign error. So if you go back, this actually should be, when I rewrote, I wrote plus 12x, and it should be minus 12x. So it should be x squared minus 12x plus 36. So this should be minus 12x plus 36. So actually my squared term should be x minus 6 squared. X minus 6 squared. And my k was wrong. So my h actually is positive 6, and my k is negative 6. So if you change yours, go back and make the correction again. Your h is positive 6 because it's x minus h, and your k is negative 6 because it's x minus h squared plus negative 6 plus k. All right, and then if you haven't already, please try number 6 on your own, and you can unpause for the solution. For the last one, you can pause the video to see the step-by-step solution, but your final answer should be the vertex is -8, -11. So please jot down any questions that you have, and we can address them next time I see you in class.